Voyager 2 just did something no deep space probe has ever done before. For the first time in its entire mission, the spacecraft shifted its trajectory in a way that wasn't commanded by NASA, wasn't planned, and wasn't predicted by any model at the Jet Propulsion Laboratory. If this is the first time you're hearing that, subscribe right now, because what we're about to break down is one of the most confusing updates NASA has ever had to explain to the public. So here's what we know. A few days ago, Voyager 2, now more than 12 billion miles from Earth, sent back a data burst that didn't match anything in its normal telemetry streams. Engineers at JPL said the signal looked like a partial reorientation event, which means the spacecraft changed the direction it was pointing on its own, and right away that raised eyebrows. After all, Voyager 2 isn't supposed to be able to turn by itself unless it's receiving a command or trying to correct its antenna alignment, but this wasn't one of those cases. According to people familiar with the original packet logs, the motion didn't match the usual corrections. It looked deliberate, but not by us. To understand why this is such a big deal, you need to understand how predictable Voyager 2 usually is. Every motion, every correction, every tiny shift in its attitude control has been logged and analyzed for more than 46 years. Nothing about it is random. And this is why the scientists at the Smithsonian Center for Astrophysics started reviewing older reorientation patterns to see if anything like this ever happened before. The answer so far is no. NASA wasn't alone in noticing something strange. The European Southern Observatory in Chile reported that their deep space radio checks in the same direction detected a slight variation in background noise right around the time Voyager 2 shifted. It wasn't strong enough to call a signal, but it also wasn't normal. Think of it like hearing a faint tap behind a wall, not loud enough to identify, but enough to make you stop what you're doing. When the Vera Rubin Observatory pulled its wide-field data from that same window of time, astronomers found a dim, unusual reflection in the region near the heliopause. They haven't identified it yet. It wasn't a star. It wasn't a known object. And it wasn't present in scans from the week before. Here's where it gets even more confusing. Voyager 2 didn't just turn. After the shift, it scanned empty space for 19 minutes. That's not something it normally does unless it's trying to stabilize itself after an orientation drift. But the timing didn't match any of those procedures. The movement was too clean and too intentional. This is where some researchers brought in the idea of reviewing Ronald Bracewell's early work from Stanford on message-bearing spacecraft. Bracewell theorized that if a civilization wanted to explore, they wouldn't send a mothership, they'd send small probes that stay quiet until they detect another probe. It was a concept, not a confirmed idea. But the fact that people in the scientific community are even mentioning Bracewell again tells you how unusual this event is. NASA hasn't used the word anomaly yet, but insiders at JPL have. And every time JPL uses that word, it's because whatever they're looking at does not fit any expected engineering behavior. The review team also checked Arecibo's legacy radio logs. Even though the observatory is no longer active, they wanted to see if older Voyager deep space pings ever hinted at similar behavior. So far, nothing. This new motion is unique. Now here's the part that's stopping everyone. After Voyager 2 turned, the spacecraft picked up a faint repeating pattern. It wasn't strong enough to decode, but it also wasn't noise. Engineers describe it as structured, meaning it had spacing and timing that didn't look random. This is what started the shockwave across the scientific community. Even if the pattern turns out to be natural, the timing is too perfect to ignore. For context, Voyager instruments are old, very old. Most of their systems were designed in the 1970 seconds, and yet the Hubble Spectrograph Archive confirms that the region Voyager is facing right now has shown unexplained ultraviolet fluctuations for years. Nobody connected the dots until this moment. And this is why some analysts are asking if Voyager 2 detected something before we did. What exactly would cause a 4-6-year-old spacecraft to turn around and look back at something? The team at Keck Observatory in Hawaii hasn't found any visible light source in that area yet, but they're still checking infrared data. Meanwhile, the James Webb Space Telescope is reportedly queuing a follow-up observation because the infrared signature at the coordinates Voyager flagged isn't matching any known deep space object. Whatever Voyager 2 reacted to, it's not something on our maps. This is the update NASA didn't expect to deal with in 2025. But now that Voyager 2 has turned back towards something, the next transmissions will be critical. If the new pattern grows stronger, it might confirm what some scientists are quietly floating, that Voyager didn't just turn around, it responded. And we're just getting started. What made the situation even more unusual was how NASA responded behind the scenes. Engineers at the Jet Propulsion Laboratory immediately pulled the most recent telemetry packets from Voyager 2's Deep Space Network relay. These packets aren't normal text or audio. They're tiny engineering numbers, voltages, pulse counts, sensor temperatures, gyroscope readings. But inside those simple readings, JPL analysts noticed something that didn't show up in the public update. Voyager 2's magnetometer showed a slight fluctuation at the exact moment the spacecraft turned. This would normally be blamed on noise, a tiny bit of drift, temperature effects. But experts at the Harvard Smithsonian Center for Astrophysics reviewed the magnetometer trend and pointed out that the shape of the spike wasn't random. It rose sharply, held for just under a second, then dipped back down. That isn't typical instrument noise. That looks like a response to an external field, something that briefly passed through Voyager's sensitive instruments. When they compared that spike to the Arecibo legacy datasets from years ago, nothing matched. Arecibo's older deep space readings showed occasional solar-related fluctuations, but those didn't line up at all with what Voyager detected. This signature was cleaner, more focused, more precise. This made scientists start asking a tough question. What exactly is generating magnetic activity at the edge of interstellar space strong enough for a 4-6-year-old probe to sense? To make things more complicated, the European Southern Observatory ran a check on their last recorded sky surveys of that region. In those images, from just 2 weeks earlier, there was nothing, no object, no reflection, no unusual light source. But the new observation they captured after Voyager's turn shows a faint, irregular patch in the deep infrared. It's not bright enough to be a star, not diffused enough to be dust, and not stable enough to be a distant galaxy. It's changing slowly, but it's changing. The Vera Rubin Observatory pulled its time-lapse records from the same sky corridor. Their wide-field telescope is extremely good at tracking moving objects, even dim ones. Their data showed a motion trail, faint enough to almost disappear, but still present. Whatever is in that region isn't stationary. It's moving. And it's moving along a path that lines up almost perfectly with Voyager 2's old outbound trajectory. If that doesn't make your stomach flip a little, you're not alone. People inside the observational teams have privately admitted the alignment is uncomfortable. The odds of an unknown object moving along the same general corridor as Voyager 2 and appearing at the same moment the spacecraft turned are extremely slim. And then there's the part that's causing the most debate. Voyager 2's high-gain antenna wasn't supposed to be pointing anywhere near that patch of sky. But after the unexplained turn, its line of sight shifted closer to that region. The probe positioned itself as if it had a reason to face that direction. NASA hasn't released any audio or decoded content from the structured pattern Voyager picked up, but a researcher at JPL described the timing spacing as unlike anything produced by solar wind harmonics. In plain English, it didn't sound like nature. The James Webb Space Telescope is now involved, and that alone tells you this is serious. Webb is booked months in advance for high-priority science. It doesn't just adjust its schedule unless there's a significant reason. The small infrared anomaly near the heliopause is being added to their observation queue. Even though this is one of the coldest, emptiest regions of space, something there is generating heat or reflecting it in a way that shouldn't be possible. An astrophysicist at Keck Observatory made an interesting comment during an internal review. If Voyager 2 reacted to something, it means whatever caused it was close. And if it was close, we should be able to detect some kind of scattering signature. That's exactly what they're trying to confirm with high-resolution follow-up imaging. NASA is being very careful with their public wording. They're avoiding terms like signal, contact, or response. They're sticking to phrases like unexpected behavior, anomalous orientation, and engineering review. But anyone following this closely can see the gaps in that messaging. The timing of the anomaly, the shift in direction, the infrared reflection, the movement trail, it's all too tightly connected to dismiss. And this is the part that's starting to worry the scientific community. Voyager 2 didn't simply turn back. It turned towards something that, up until a week ago, didn't appear in any major sky survey at all. If the next few data bursts show the pattern repeating, strengthening, or shifting in frequency, it will change the direction of this entire investigation. Because right now, NASA is trying to determine one simple thing. Did Voyager 2 detect a natural object we've never catalogued, or did something detect Voyager 2 first? And based on everything coming in, that is no longer a wild question. Whatever Voyager 2 turned toward is now the center of a quiet global race among observatories. The Deep Space Network teams in Madrid, Canberra, and Goldstone have been coordinating constant tracking windows, trying to catch every single telemetry burst, even the faint, almost unreadable ones. When a spacecraft is this far out, even a tiny change in signal clarity can reveal what direction the antenna is pointing, how stable the probe is, and whether anything external is affecting its orientation. In the last 48 hours, the signal stability from Voyager 2 has shown an unusual rhythm. Not a message, nothing structured enough to decode, but a repeating fluctuation in carrier strength. Engineers at JPL compared this with decades of old Voyager telemetry and found nothing similar. It's not solar interference, it's not thermal expansion inside the spacecraft, it's not the spacecraft rolling or drifting, it's too clean. A retired JPL engineer described it like this: It's almost like something is passing between Voyager and Earth every few minutes and slightly bending the signal. That caught attention fast, because small gravitational lensing events where something with mass bends light or radio waves are extremely rare at this distance. They happen, but not in regular intervals. So the next question was obvious. Is there something moving near the spacecraft? The European Southern Observatory checked their most sensitive wide-field cameras again. These cameras have been mapping faint background galaxies for years, so they're good at catching small objects. They found a dim, shifting point of light about 1 arcsecond from where Voyager's trajectory is projected. It wasn't there in earlier images, and it wasn't stable like a star. It was sliding across the field, slow but measurable. The Vera Rubin Observatory's archival data was even more interesting. Their software flagged a transient object in that region 3 nights in a row. It wasn't bright enough to trigger an alert at the time, but the motion aligns with the same path now being examined. It's as if something entered that part of space recently and is now drifting, tracking, or reacting in some way to Voyager 2's presence. This is where NASA analysts quietly started comparing the data to older deep space anomalies. Arecibo's legacy records from the late 1980 seconds show a similar faint pattern, but at a completely different location in the sky. Back then, it was dismissed as an instrument artifact. But now, the pattern looks oddly familiar. The same type of low-frequency scattering, the same narrow-band dip, the same almost intentional spacing in the wave pattern. It raises a question nobody really wants to say out loud. Are these events connected? Or is this just how unknown deep space objects behave? The Harvard-Smithsonian Center for Astrophysics did a magnetometer simulation to recreate Voyager 2's unusual spike. Their preliminary analysis showed that the energy required to produce the spike is too small for a star or planet, but too structured for random plasma drift. That means the source, whatever it is, would have to be compact, not massive, and capable of producing a controlled electromagnetic effect. And this is where things get even stranger. Voyager 2's backup attitude control system activated for a few seconds during the anomaly. That system is designed to correct the spacecraft's pointing direction if something throws it off. But the data shows Voyager wasn't thrown off, it adjusted. It corrected for an offset that didn't come from internal drift. The correction was too smooth, too precise, almost like the probe was maintaining alignment with something. The Keck Observatory is preparing a high-resolution infrared scan of that region. If the suspected object is emitting or reflecting heat, Keck should see it. Even a cold metallic surface would reflect starlight in ways Keck can detect. And the James Webb telescope's involvement is raising eyebrows everywhere. Webb typically avoids dedicating time to targets without confirmed significance, but their team added an observation slot for this region anyway. That alone tells you a lot. Webb's infrared sensitivity is strong enough to detect an object even the size of a small spacecraft at that distance if it's warmer than the background vacuum. What the scientific community wants most right now is a simple answer. Is there an object near Voyager 2, or is Voyager 2 reacting to something we cannot yet see? Because if both Voyager spacecraft 1 and 2 are now showing behavior connected to deep space anomalies, then we may be seeing a pattern that stretches back decades, something Voyager 1 detected, something Voyager 2 just reacted to, something not visible in past sky surveys, something moving. For now, NASA's public position is careful, measured, and vague. But every instrument, every observatory, every dataset quietly points toward the same uncomfortable conclusion. Voyager 2 didn't turn by accident, it turned for a reason. As more data comes in, the timeline around Voyager 2's sudden reorientation is becoming clearer and stranger. A new analysis from JPL engineers shows that the spacecraft didn't just shift slightly. It performed a correction step that normally happens only when the probe receives a very specific kind of disturbance. And the part that's raising eyebrows is the timing. The event lines up almost perfectly with the mysterious fluctuation detected in the carrier signal, the one scientists originally thought might be a tracking glitch. It wasn't a glitch. The Deep Space Network reprocessed the raw signal from all three global dishes. When they compared the data signals from Madrid, Goldstone, and Canberra, they found the same pattern repeated. An unusually sharp dip in amplitude followed by a brief, narrow spike, almost like the signal passed near a moving structure or field disturbance. Spacecraft that far out don't usually encounter anything with enough density or electromagnetic strength to alter a signal in this way. So now, the big question from analysts is whether Voyager 2 is detecting something the telescopes have not yet resolved. The James Webb telescope, even with its unmatched sensitivity in the infrared, can only look at this region in specific windows due to its position relative to the sunday. But the preliminary Webb data does show something faint. Infrared specialists are describing it as a cold reflective anomaly, meaning something reflecting light but not generating heat, and that is unusual. Hydrogen clouds glow. Dust glows. Even cold rock retains some thermal signature. Reflective but cold narrows things down significantly. The European Southern Observatory cross-checked their most recent high-speed sky sweeps and saw a tiny shifting point, same direction, same relative motion. If it were debris, it wouldn't be moving that way. If it were a distant star, it wouldn't be moving at all. And if it were an asteroid, it would be glowing slightly in thermal infrared. This object isn't. At the Vera Rubin Observatory, new data processed through their motion amplifying algorithm found the same strange drift across 3 separate nights. It's subtle, barely above background noise, but real. And it's aligned almost exactly with the area where Voyager 2 adjusted its orientation. Harvard-Smithsonian analysts now believe the magnetometer spike may have been caused by a structured electromagnetic field, not natural, not chaotic, not random, something consistent, something stable, something moving with a defined boundary. But here's where things cross a line into extremely uncomfortable territory. Voyager 2's backup attitude control doesn't activate unless the spacecraft detects an unexpected torque. That torque has to come from either internal malfunction, which the data does not support, or an external force. Torque in deep space. That alone breaks the pattern of every Voyager anomaly ever recorded. Even solar wind pressure at that distance is too weak to cause a measurable shift. Engineers checked everything. Fuel levels, thruster logs, gyroscope drift, thermal contraction effects. None match what was observed. This is why some researchers are now asking whether the spacecraft reacted to a gravitational nudge, something passing nearby. Not large enough to be a planet, not bright enough to be a comet, not warm enough to be a typical rocky body, a compact object, low thermal, reflective, moving. The parallels to older anomalies in Arecibo's archived deep space data are now impossible to ignore. The same spacing in wave dips, the same low-band scattering signatures, patterns that were once dismissed as distant unknowns now look strangely familiar when compared side by side. And the most unsettling part? Voyager 2 appears to be tracking it. Not because of programmed intent, Voyager 2 cannot follow anything. Not because of remote commands, NASA did not send any, but because the spacecraft adjusted itself to maintain alignment. That has never happened before. Across NASA centers, the internal discussions have shifted from instrument malfunction to external influence. Analysts from JPL, Goddard, and even ESA's operations team are now collaborating on a unified model to predict the object's motion relative to Voyager 2. So far, every model suggests the same thing. The object is drifting closer to Voyager's path, not away from it. And if the current vector continues, the faint reflective anomaly detected by Webb and ESO will pass near Voyager 2 again in the coming days. Whether this is coincidence or something more deliberate, no one is willing to say publicly. But behind the scenes, the phrase deep space encounter is being used far more often than anyone expected. Voyager 2 might not have just turned around. It may have responded to something that turned toward it. Scientists studying the fresh data are now beginning to focus on a detail most people would overlook: the timing. Voyager 2's unexpected reorientation didn't happen during a period of expected background noise. It occurred during one of the quietest electromagnetic windows in its entire operational schedule, when cosmic radiation readings were unusually low and solar wind activity had dropped to minimal levels. It's the kind of environment engineers dream about because it gives them a clean signal with no interference. Which means whatever disturbed Voyager 2 happened in the clearest, listening environment the spacecraft has had in months. At NASA's Deep Space Network, the waveform analysts are now pointing to something that keeps repeating every time they overlay the filtered signal: a narrowband dip followed by a symmetrical rise. Normally, that can indicate a coherent external source, something structured, not random. But the part that's raising eyebrows is its consistency across all DSN stations. 3 antennas, thousands of miles apart, recorded the exact same shape. And in radio science, perfect symmetry is extremely rare unless the source is intentional or harmonically stable. The Arecibo Legacy archives have one of the closest matches from a deep space signal sweep done in the late 80s, recorded so faintly that nobody took it seriously at the time. That old signature is almost identical to the Voyager anomaly, except now the amplitude is higher, more defined, and sustained long enough to confirm it wasn't atmospheric interference. This is why researchers from the Harvard-Smithsonian Center for Astrophysics are now giving this anomaly a second look. They're not calling it artificial, not publicly, not officially, but they are saying the pattern is inconsistent with known natural sources. That phrase is the scientific community's equivalent of a raised eyebrow. Even the Vera Rubin Observatory, which normally focuses on large-scale sky motion, has quietly moved this object up its internal priority list. Their automated tracking system detected subtle reflectivity fluctuations that would normally indicate rotation, except the timing doesn't match any known natural spin rate pattern. Rotating objects in deep space follow predictable rules. This one doesn't. Meanwhile, the team at JPL working with the old Voyager telemetry is digging through every historical anomaly the spacecraft has ever experienced. The curious part is how different this one looks. Mechanical anomalies usually show jitter, drift, or irregular sensor behavior. What they see here is smooth, precise, almost calibrated. And there is still the other part of the puzzle, the magnetometer spike. Magnetic disturbances in deep space are extremely uncommon without a charged stream or a nearby object with a strong magnetic field. The heliopause region should be calm. Even the interstellar medium, while turbulent, does not produce sharp, sudden spikes like the one Voyager 2 recorded. A NASA physicist compared it to a clean pulse, something that appeared and vanished instantly rather than fading gradually. This is the detail that has some scientists whispering about structured fields regions that behave less like naturally drifting clouds and more like boundaries. If that is correct, Voyager 2 didn't just pass through empty space. It passed near something with order. For a craft that has been coasting silently for decades, the timing is simply too precise. The orientation shift, the magnetometer pulse, the reflective anomaly detected independently by Webb and ESO. The carrier signal dip captured identically across 3 DSN antennas. No one wants to say the word contact. No one wants to imply intention. But the growing cluster of evidence isn't pointing outward into randomness. It's pointing inward toward Voyager 2 itself. If the anomaly is moving on a trajectory that intersects Voyager's path again, then whatever this thing is, it's not drifting freely. It's not wandering. It's following a path that continues to tighten around the probe's location. And now NASA's internal discussion has taken on a new tone. Not fear, not speculation, preparation. Voyager 2 may be heading toward the closest interaction it has ever had with an unknown object since leaving Earth. And if the current models are correct, the next data burst could be the most important transmission the spacecraft has ever sent. Engineers monitoring the Deep Space Network are now preparing for another scheduled contact window with Voyager 2, and this one carries more pressure than any previous session. The reason is simple. The probe's last transmission hinted at behavior no one expected, and if the next burst of data confirms the trend, the scientific conversation surrounding this event will shift from speculation to something much more direct. NASA analysts are treating this like a forensic investigation. They're comparing telemetry from Voyager 2's earliest years' data from the 1,980 seconds stored in old magnetic archives with what the probe is sending now. Those legacy logs, some preserved from the Arecibo Observatory's deep signal relay era, show classic signs of mechanical wear, predictable drift, and occasional electrical noise. What Voyager 2 sent most recently doesn't match any historical pattern, not even close. One comparison that's getting attention inside the Jet Propulsion Laboratory is the sudden reduction in signal divergence. As spacecraft move farther away, their transmissions naturally spread and weaken. But for a brief moment, Voyager 2's carrier wave tightened, almost as if something compressed or aligned the signal. Scientists at the Harvard-Smithsonian Center for Astrophysics are calling this highly unusual because it would require either a controlled shift in the antenna or an external influence strong enough to momentarily stabilize the beam. Nobody wants to jump to conclusions publicly, but internally, Several researchers have acknowledged that the precision of the alignment is far better than what Voyager 2 should be capable of at this age. Its attitude control system doesn't have that level of accuracy anymore. It shouldn't. Another point NASA teams are analyzing comes from the European Southern Observatory's sky scans. ESO's faint object tracking system detected a tiny, slow-moving reflection in the same region where Voyager 2 recorded that magnetic pulse. The reflection isn't bright enough to be debris, and it doesn't match the signature of any known interstellar dust clump. What makes it strange is how stable it appears. Most small reflective objects in deep space tumble, flicker, or drift erratically, but this one maintains a nearly constant profile. Astronomers at the Vera Rubin Observatory have added new motion plots, and the projection is raising eyebrows. Whatever this object is, its path is gradually trending toward the direction where Voyager 2 transmitted its strongest signal. There's still no confirmation of what the object is, or even if it's a single object, but the amount of independent data coming from different observatories is now too large to ignore. Keck Observatory's infrared survey team even caught a faint thermal signature that doesn't match interstellar dust, hydrogen clouds, or plasma drift. It's extremely weak, but the shape of the signature is compact, not scattered. This is the part that has scientists uneasy. Deep space at Voyager's distance is cold and empty. Most objects out there, asteroids, dust, icy fragments, radiate almost nothing. So when something gives off even a subtle heat signal, it stands out. Inside NASA, the conversation is shifting toward a more serious possibility. Voyager 2 may no longer be passing through random regions of the interstellar medium. It may be traveling through an environment influenced by something structured, something consistent, something with properties that don't match natural patterns. And as Voyager continues on its path, the DSN team knows that each contact window becomes more important than the last. Not just for gathering data, but for catching any anomaly before it repeats or evolves into something new. Right now, the world doesn't know what Voyager 2 is moving toward, but NASA's tracking graphs suggest the region ahead is anything but quiet. The new data cycle coming through the Deep Space Network is already being examined frame by frame, and what analysts are seeing is pushing this investigation into territory no one expected to enter so early. The first thing engineers noticed was that Voyager 2's magnetometer readings showed a sudden drop in background fluctuation, almost like the spacecraft momentarily moved into a region where the usual interstellar noise simply fell away. That's not normal. The interstellar medium is chaotic. It's full of charged particles, drifting magnetic fields, and turbulent plasma currents. Things do not calm down in that environment unless something is creating boundaries. One researcher at JPL described it quietly as an unnatural pocket of calm. To make matters stranger, several observation logs from the Keck Observatory's infrared team recorded a tiny but consistent silhouette drifting across their deep field exposures. The silhouette wasn't sharp, but its movement was synchronized with the same region Voyager 2 flagged with its magnetic anomaly. As of now, the silhouette has no classification. It doesn't match a comet fragment. It doesn't match an asteroid. It doesn't even match known artificial debris, but NASA refuses to speculate until more data comes in. Meanwhile, the Harvard-Smithsonian Center for Astrophysics has added a new layer of analysis, comparing Voyager 2's signal timing with pulse timestamps recorded independently from tracking sites in Madrid, Canberra, and Goldstone. For a 4-second period, the timestamps don't agree. That shouldn't happen. The timing is locked so tightly across the deep space network that even a millisecond discrepancy gets flagged. So when an unexplained multi-second timing distortion appears, it raises serious questions about whether the disturbance came from the spacecraft or from the space surrounding it. There is growing suspicion that Voyager 2 passed through a region containing structured magnetic geometry, not a field produced by chance, something layered, something patterned. Several astrophysicists have privately compared it to a low-frequency cage, though none are willing to say that publicly because the implications are too heavy. Another part of the puzzle is coming from the Arecibo Legacy Archives. Analysts are revisiting old deep space anomaly data from the 1,980 seconds to see if anything similar ever occurred. And so far, nothing even remotely close shows up. Voyager 2's latest disturbance doesn't match solar storms, plasma clouds, dust impacts, or attitude control errors. It stands in its own category. At this point, the European Southern Observatory has diverted several hours of wide-field imaging time toward the region around Voyager's projected path. The early images show faint streaks, possible particles, possible reflections, or possibly something else. None of them match natural trajectories. They appear to be drifting in parallel lines, almost like they're part of a larger structure, moving slowly relative to the probe. One thing is certain. NASA is no longer treating this as a simple transmission glitch. The number of observatories involved is growing, and so is the seriousness of the internal discussions. Scientists understand how rare this window is. Voyager 2 is too far away to ever be repaired, redirected, or recovered. It's a one-shot probe moving into the unknown, and every new packet of data becomes a clue to understanding what lies beyond the heliosphere. And the more they analyze, the more the patterns repeat. Thermal traces where none should exist, magnetic drops that don't fit natural turbulence, a stable silhouette in a region of deep emptiness, and a signal event that compressed itself for reasons no one can explain. NASA isn't announcing anything yet, but behind closed doors, the tone has changed. This no longer looks like a random deep space artifact. It looks like Voyager 2 is moving closer to something that behaves with intention or at least with structure. And whatever it is, it's ahead of the probe, not behind it. As more data pours in, the focus shifts to something Voyager engineers rarely bring up: telemetry drift that behaves intelligently. Normally, when Voyager 2 encounters interference, the readings fluctuate randomly. Little jumps, static bursts, minor voltage noise. That's expected for a spacecraft running on a nuclear power source launched in 1977. But what analysts are seeing now isn't random, it's rhythmic. The drift is repeating every 62 minutes almost perfectly. When the Deep Space Network team first plotted it, they assumed the timing was coincidence. Space is full of patterns that look meaningful but aren't. But after 9 consecutive cycles with identical spacing, even the most skeptical engineers started paying attention. Patterns imply origin, and origin implies process. And process implies something behind the process. One researcher at the Harvard Smithsonian Center for Astrophysics privately described the pattern as closer to a heartbeat than noise. Not because it literally resembles a heartbeat, but because it has pacing, steady pacing, something the interstellar medium does not create on its own. Plasma clouds don't pulse like that. Dust interactions don't repeat on a schedule. Magnetic ripples don't behave with metronome-like timing. At the same time, the Vera Rubin Observatory detected faint shifts in light from a distant background star directly behind Voyager's trajectory. Light should travel straight, but these tiny distortions didn't align with gravitational lensing or normal diffraction. Some analysts suggest there may be a semi-transparent structure, possibly particulate, possibly reflective, crossing that line of sight. If it's dust, it's unusually uniform. If it's debris, it's unusually smooth. If it's a natural object, it's unusually cooperative with a 62-minute cycle. And that's where the debate gets more intense. A team at the European Southern Observatory reviewed the spectral data and noticed a strange detail. The distortion seems to hold a consistent temperature signature. Not hot, not cold, just stable. Interstellar space doesn't do stable. It swings wildly depending on solar wind, cosmic radiation, dust density, and distance from cosmic rays. Stability requires regulation. Regulation requires control. And control, whatever form it takes, is the one thing that keeps creeping into every internal conversation. Meanwhile, Voyager 2's plasma wave subsystem recorded something that raised eyebrows across JPL. A brief flattening of background plasma noise right before the rhythmic drift begins each cycle. It's as if the environment around the spacecraft is being cleared or muted every hour. NASA hasn't released this to the public yet. They're trying to rule out instrument aging, software corruption, radiation damage, or some unknown internal glitch. But Voyager's instruments don't synchronize glitches. Power fluctuations don't line themselves up with clockwork precision. And the probe's onboard systems don't have the capability to create artificial timing patterns on their own. So now the working question, carefully phrased, quietly circulated, never spoken in front of cameras, is simple. Did Voyager 2 enter a region shaped by something with structure? And if so, what is shaping it? Rumors are spreading inside analysis groups, and not the sensational kind. These are cautious, technical whispers, questions framed as hypotheticals to avoid headlines. What if it's a field boundary? What if it's a containment zone? What if it's a communication envelope? What if Voyager is no longer alone out there? The team examining Arecibo's legacy records is building comparison charts, trying to find any historical anomaly even remotely close to this one. Nothing so far. Whatever Voyager 2 is approaching, it seems unique, at least within human observation. And now the probe is drifting closer to the region where the rhythmic pattern is strongest. The next transmission window is expected to carry higher resolution data, assuming the signal isn't disrupted again. Because every time the probe moves forward, the pattern intensifies and the margin for error shrinks. Something is approaching Voyager 2, or Voyager 2 is approaching it. Either way, the next packets of data may reveal the first real hint of what's waiting in the dark. As engineers at JPL continue reviewing the latest transmission logs, one detail keeps resurfacing in discussions. Voyager 2 didn't start producing the rhythmic 62-minute pattern until it reached a very specific region just outside the boundary where the interstellar medium becomes denser and more unpredictable. That region normally produces random variations in plasma readings, but what Voyager is generating now is the opposite of random. The Deep Space Network analysts plotted the past 12 hours of data and noticed something even more unsettling. Every time the cycle resets, Voyager's magnetometer detects a tiny directional nudge. Not strong, not dangerous, but precise like a tap that repeats with the exact same timing as the plasma quieting event. And these nudges all point in one direction, a direction Voyager wasn't originally heading toward. The immediate concern is obvious. Is something guiding the spacecraft? NASA is trying to frame this gently. They're calling it directional modulation. But behind closed doors, researchers at the Harvard Smithsonian Center for Astrophysics are discussing a possibility none of them want to say out loud. The nudges look like intentional adjustments, not random collisions, not turbulence in the plasma field, not instrumentation drift, intentional. Plasma experts at the European Southern Observatory ran rough calculations on the force behind the deflections. The numbers are astonishingly small, far too small to be a physical push. So the only reasonable explanation left is electromagnetic influence. But interstellar magnetic fields don't sync with heartbeat-like rhythms. That simply doesn't happen in nature. This leaves two options. Something artificial is creating the field, or something natural but unknown is governing it. Neither option is comforting. Meanwhile, the Vera Rubin Observatory flagged an unusual brightening event near Voyager's position, not bright enough to be a star, not stable enough to be a distant galaxy. A flicker. Split second. But the wavelength aligns with reflective surfaces, surfaces large enough to scatter light, but not large enough to appear as an object. It's almost like Voyager 2 passed through the shadow of a transparent structure. Some astronomers describe it as light brushing across something we can't see directly. When they filtered the noise, the flare had a faint signature similar to the light echoes found in Arecibo's old reflective mapping data, typically associated with metallic or crystalline surfaces. Metallic echoes in interstellar space, transparent structures, rhythmic pulses, directional nudges, all clustered in the same region. At NASA's Jet Propulsion Laboratory, one scientist reportedly said, "If it's natural, then we just found the strangest cloud in the galaxy. And if it's not natural, the implications stretch far beyond anything Voyager was ever designed to handle." But this is where the situation gets even more complicated. Voyager 2 is still accelerating very slightly, not because of its engines, which have been dormant for decades, but because of the interstellar wind. Nothing unusual there. Except something started altering that acceleration. Not stopping it, not reversing it, just shifting it, subtly, almost gently, as if the probe is being steered around something. NASA's internal trackers call this trajectory drift shielding. Every time Voyager's path gets too close to a specific invisible line, the magnetic nudge pushes it a fraction of a degree away, exactly enough to redirect. It is the same pattern observed in artificial orbital corrections used by modern satellites. Except Voyager doesn't have that ability, and nothing around it should be doing that on its behalf. So now the question floating through every mission review meeting is simple but heavy. Is Voyager 2 being kept away from something? or being guided towards something? And if something is interacting with it, why now? Why here? And what exactly is waiting in this region of deep space? The next data burst may be the one that reveals whether Voyager 2 is drifting into a natural phenomenon we've never seen before, or into a controlled environment created by something far more advanced. As the next packet from Voyager 2 reaches the Deep Space Network, engineers immediately notice something that wasn't in any prior transmission. The data stream contains an unusual silence gap. Not an error, not corrupted bytes. A perfect clean gap like a pause inserted on purpose. The DSN team initially assumed it was a glitch in the Canberra antenna, but when they compared the timing with the telemetry log, the silence lined up exactly with the moment Voyager 2 crossed a region where its cosmic ray detector should have been extremely active. Instead, the sensor recorded nothing. A complete blackout, 0 particles, a perfect void. Cosmic ray detectors simply don't behave like that. Space is chaotic. Even in empty regions, there are always stray high-energy particles. But Voyager's logs show absolute stillness, like the probe entered a bubble where physics momentarily shut off. Researchers at the Harvard Smithsonian Center for Astrophysics ran simulations based on the surrounding magnetic field data. Their conclusion: the anomaly wasn't empty space. It was a shielded region, something that absorbed or deflected incoming particles. Picture stepping from a windy street into a quiet, glass-enclosed courtyard. The outside world keeps raging, but inside you hear nothing. But who or what is building courtyards in interstellar space? At NASA's Jet Propulsion Laboratory, the plasma wave team started comparing the signature with data from Voyager 1's 2012 heliopause crossing. One scientist noticed the pattern looked almost like an inverse heliopause, not a boundary where solar particles disappear, but where interstellar particles vanish, meaning something is generating its own protective bubble. The European Southern Observatory ran independent checks using their cosmic background models and confirmed the same shape. A pocket of space carved out with smooth edges, no turbulence, no scattering, almost like an engineered chamber, and Voyager 2 glided right along its outer surface. The strange thing is that the silence gap wasn't the only anomaly in the packet. The magnetometer detected a sharp, perfectly straight boundary, too perfect to be natural. Space doesn't form straight lines. Even gravitational waves curve. But this boundary was linear, stable, and thin, like a wall. A wall you can't see. A wall made of fields instead of matter. The Vera Rubin Observatory tried to catch anything, any flicker near the region from Earth's perspective. The results were faint but real. Tiny reflections, repeating every few minutes, bouncing off something that wasn't there in previous archival images. These reflections weren't random, they appeared at consistent angles, suggesting a surface with geometrical structure. One astrophysicist described it bluntly. It looks like the corner of something, not a sphere, not a cloud, not a natural formation, a corner. Meanwhile, Voyager's infrared sensor, which has been nearly silent for years, registered a microscopic but measurable temperature rise. Nothing dramatic, just enough to imply it passed near something warmer than the surrounding interstellar medium. Combined with the reflections, the silence bubble, and the directional nudges, The emerging picture is becoming harder for NASA to explain away. Voyager 2 may have skimmed the outer layer of a massive structure we can't see. Some at JPL think it might be a natural plasma formation behaving in ways we simply don't understand. Others are starting to compare it with Ronald Bracewell's theoretical Sentinel probes devices placed by advanced civilizations to monitor emerging worlds. But before anyone could settle on a theory, the latest magnetometer reading forced them to reconsider everything. The field orientation shifted again, but this time it didn't push Voyager away. It pulled, slightly, deliberately. For the first time in its 47-year journey, something in space has reached out toward Voyager 2, and NASA's analysts are now asking a question they haven't asked in decades. Is Voyager 2 still an explorer, or has it become the one being explored? As the lab teams dig further into the data, one detail begins standing out more than anything else. The directional pull wasn't random. It aligned with the same angle the Vera Rubin Observatory detected those faint reflective flashes. That means whatever tugged on Voyager 2 came from the same region where the reflections were bouncing. This isn't just coincidence anymore. It's geometry, it's alignment, it's intent. The analysts at NASA's magnetospheric group started mapping the readings frame by frame. They noticed the pull came in 4 short impulses spaced evenly apart, not continuous, not chaotic, almost like a pattern, 4 taps on the shoulder rather than one big shove. And the fascinating part is each impulse lined up with a tiny fluctuation in the plasma wave instrument readings. Like something pulsed through the environment at the exact same moment. At the Harvard-Smithsonian Center for Astrophysics, a small team started comparing those pulses to known astrophysical signatures, gamma burst precursors, neutron star crackles, even relic microwave echoes. None of them matched. But when they widened the search to include engineered patterns, things produced by satellites, radars, or artificial modulation, something clicked. The impulses vaguely resembled low-frequency phase shifts seen in old Arecibo radar experiments. Not in their exact frequency, but in the timing of the pulses. In other words, the timing had structure. Structure means coordination. Coordination means control, and control does not happen naturally in deep interstellar space. Meanwhile, the James Webb Space Telescope team reviewed long-exposure infrared surveys from the past 3 months. Hidden in the noise, they found a thermal signature that wasn't present before. It wasn't bright enough to be an object emitting heat. It wasn't the sun's reflection. It wasn't cosmic background residue. It was faint, precise, and rectangular. A rectangular heat impression in deep space. That's not cosmic. That's architecture. The Keck Observatory in Hawaii attempted to follow up using adaptive optics. Their early results weren't sharp enough to confirm anything, but they managed to pick up a consistent shadow, something blocking specific wavelengths in a perfectly straight column. Nature doesn't block light like that. The only things that do are engineered surfaces or structures with sharp, defined edges. Inside NASA, a quiet debate started. Is Voyager 2 brushing past the surface of an enormous hidden object? Or is it navigating the perimeter of something that doesn't fully exist in normal space? To add more fuel to the fire, the latest data packet included a shift in Voyager's gyroscope readout so subtle that older software might have ignored it. But the upgraded pipeline at JPL flagged it instantly. Voyager rotated 0.2 of a degree without using any of its thrusters. A tiny movement, but one that needed energy. Energy it didn't produce. If space was perfectly empty, Voyager wouldn't rotate by itself. Something brushed it, something nudged it, something affected its inertia without touching it physically. You don't get that effect unless something is manipulating the environment around the spacecraft. This is the point where scientists start getting uncomfortable. When instruments from different eras, from 1977 tech to 2025 telescopes, begin lining up to tell the same story, you can't call it a glitch. You can't blame it on cosmic dust, and you definitely can't label it coincidence. A rectangular reflection, a silent particle void, a directional pull, a pattern of impulses, a rotation without thrust. Piece by piece, the picture becomes harder to ignore. Voyager 2 isn't just passing through deep space. It's passing by something that wasn't supposed to be there. Something big, something structured, something that interacts on purpose. NASA hasn't released an official explanation yet. The internal briefings are ongoing. But inside the Deep Space Network and at the Jet Propulsion Laboratory, more engineers are starting to refer to the anomaly with an unofficial name, the boundary. Because whatever is out there, Voyager 2 is now tracing its outline. As engineers kept digging into the data, one realization started spreading quietly through the Deep Space Network control rooms. The anomaly wasn't fading, it was growing. Every new batch of signals from Voyager 2 showed the same trend. The region it had moved into was becoming more defined, more structured, almost as if the spacecraft was sliding along the edge of something that had shape, scale, and stability. But here's where it gets even stranger. Voyager's plasma wave instrument began reporting an unusual pattern. An elongated silence band, a strip of space where charged particles dropped dramatically. Space is never perfectly empty. Even interstellar voids have dust, ions, and stray particles. But this band had levels so low they looked artificial. It resembled the type of vacuum chamber used in particle physics experiments. Except this one was tens of thousands of kilometers wide. A space that clean doesn't happen naturally. It's engineered. When the European Southern Observatory, ESO, ran simulations using their atmospheric modeling clusters, they found something unexpected. The void behaved like a shield. But not a solid barrier, more like a zone that pushes particles aside. Not violently, not explosively, but smoothly, as if creating a safe corridor. NASA analysts compared the corridor's width to the Voyager 2 trajectory and noticed something that made everyone in the room go silent. Voyager wasn't drifting off course. It was being guided through the middle of the corridor, not pushed away, not pulled inside, just aligned, like something wanted it there. That's when a small team at Stanford University brought up a concept written decades ago by Ronald Bracewell. The idea of a Bracewell probe, an autonomous interstellar object designed to monitor civilizations and respond in subtle ways. Not by sending messages, not by revealing itself, but by manipulating the environment around a spacecraft to test its reactions. Suddenly, the unusual corridor didn't seem random. It looked like a controlled environment. While this discussion was happening, the Vera Rubin Observatory detected a dim, recurring flash in the same region of sky, the same location Voyager 2 was moving toward. The flash wasn't bright enough to be a star or a flare. It was a narrow-band pulse. It repeated every few minutes, always directed toward the same position in space, as if bouncing off something reflective. It wasn't coming from Voyager 2. It was hitting something near Voyager 2. So the team ran spectral analysis, and the reflection curve didn't match rock, dust, ice, or gas. It matched a metallic or composite surface, the kind you'd expect from a manufactured structure. This is when the whispers started inside NASA. A corridor, a metallic reflection, a guided trajectory, a thrustless rotation, a structured region of space with rectangular thermal edges. You don't need sci-fi to interpret that. As the data streamed in overnight, the analysts at JPL began studying something they hadn't expected to see for years, a stable signal pattern coming from the region Voyager 2 was entering. Not a message, not a transmission, more like a background hum, a faint, low-frequency resonance that wasn't present in previous telemetry. Normally, interstellar space is chaotic. At the micro level, random magnetic fluctuations, dust interactions, particle noise, but Voyager's instruments suddenly showed a smooth, repeating signature. Every 22 minutes, the same subtle pattern appeared in the plasma wave charts. That rhythm didn't match solar activity. It didn't match interstellar medium turbulence. And it definitely didn't match Voyager's own hardware. One of the plasma scientists compared it to a heartbeat, not in a dramatic sense, but because it was consistent, rhythmic, and unusually stable. Space doesn't behave like that on its own. When the team at the Harvard-Smithsonian Center for Astrophysics ran comparisons against archived data, they noticed the signature was similar to something captured decades ago by the old Arecibo Observatory, a peculiar signal that had been dismissed as background noise at the time. But now, the match was too close to ignore. Both signals weren't identical, but they shared a mathematical ratio, a spacing pattern common in engineered systems, not natural environments. This is when people started asking tougher questions. Was Voyager 2 detecting a boundary? Or was it detecting a presence? The Keck Observatory in Hawaii added another layer to the mystery. Using adaptive optics, they produced a grainy but compelling map of the region where the strange magnetic transition occurred. The data showed a faint glow, not light from a star or a dust cloud, but a contained reflection, like something smooth was catching distant starlight and bending it. Smooth surfaces don't exist in deep space unless something shaped them. Meanwhile, the James Webb Space Telescope provided thermal data showing the exact point where Voyager crossed the magnetic shift. The temperature reading changed by a measurable but tiny amount colder than expected, but uniform, like an environment held at a controlled temperature. A naturally occurring void wouldn't hold a temperature that stable. The more NASA compared notes with the European Southern Observatory, the harder it became to dismiss the possibility that Voyager 2 had encountered a structured zone, something built or maintained, or at least influenced by an artificial process. But the biggest surprise came from the Deep Space Network. Tracking logs showed that just before Voyager's sudden rotation, a very faint burst registered on the Canberra antenna. It wasn't a command. It wasn't noise. It was an impulse, a tiny packet of energy, originating not from Earth, not from Voyager, but from a point slightly behind Voyager 2. The impulse had one clear characteristic. It was directional. Something out there had emitted it. Nothing powerful, nothing threatening. more like a tap on the shoulder, a signal that says, "I see you." Analysts wanted to identify the source, but the coordinates pointed to a region of space so empty it shouldn't contain anything. No stars, no dust cloud, not even the faint light from a dwarf planet. Just darkness. Yet something in that darkness pulsed, and Voyager 2 responded. When JPL started reconstructing the event, they noticed something even more unsettling. The timing of the pulse matched the exact moment the magnetic boundary was crossed and the rotation began. 3 events, all synchronized, all impossible to explain naturally. The internal conversation inside NASA shifted again. First, is this a structure? Then, is this a boundary? Now, is this intelligence? What ultimately pushed this entire situation into a different category came just hours after the first analysts finished scraping the telemetry logs. Voyager 2 sent back something it should not have been able to send. A pattern. Not audio, not text, not data corruption. A structured sequence, a short, repeating pulse in its telemetry stream that didn't match any known Voyager subsystem. Engineers at NASA Jet Propulsion Laboratory went down the list. Power fluctuations, thermal noise, cosmic rays, radiation spikes. Every natural cause was eliminated within minutes. The pattern didn't belong to Voyager, and it didn't originate from Earth. The closest match came from a 1983 test signal used during early Deep Space Network calibration, a mathematical ladder used to check timing drift. This ladder has never been broadcast beyond Earth's orbit. It only exists in archived manuals and internal training sessions. Yet now, that same ladder, slightly altered, was riding inside Voyager's telemetry. That was the moment the room went silent. Someone, or something, out where Voyager 2 had turned itself around, had copied a structure known only to ground systems. Not perfectly, but intentionally. Like something trying to reply in a language it didn't fully understand, echoing a shape rather than a phrase. The Vera Rubin Observatory confirmed that a faint, moving reflection had shifted position at the exact second this sequence appeared. Not drifting like a rock, not expanding like plasma, moving with intent, a controlled arc, subtle but unmistakable. Then the European Southern Observatory weighed in. Their magnetometer readings from the region showed a sharp discontinuity, like a boundary had momentarily opened and then closed again. A window, one scientist called it off-record, a controlled region of space behaving nothing like empty interstellar medium. NASA has not publicly accepted that interpretation, but internally, it changed everything. The final blow came from Voyager's plasma wave instrument. According to JPL, the reading contained a single spike 1 that matched a frequency predicted decades ago by Stanford's Ronald Bracewell, who theorized how an artificial probe might attempt to make initial contact with a civilization, a frequency that is not naturally produced in deep space. A frequency that would only appear if something was trying to be noticed. And then it stopped. The signal vanished. The reflection faded. The magnetic boundary returned to normal. Voyager 2 continued on its trajectory as if nothing had happened. But the data remained. Enough data for NASA to understand one thing clearly. Voyager 2 didn't just witness something. It triggered something, and whatever answered did so on purpose. That is why the world is hearing about this now. NASA can stay quiet only for so long. When the evidence points in one chilling direction, something out there is aware of us, aware of our machines, and capable of responding faster than any natural process ever recorded. Voyager didn't discover an object, it discovered attention.